Starting small, but the goal is to build massive orbital data centers that will make computing more efficient and less of a burden on the limited resources down here on Earth.
I can see why it seems like a long shot to some people. To me, though, the reason for doing this is that the potential impact is absolutely massive. So even if you think there's a small percentage chance of it working, then it's worth taking this kind of risk.
Philip Johnston and his team at StarCloud recently made aerospace history when they launched a satellite into orbit carrying an NVIDIA H100 GPU.
This is the first time anybody's tried to launch data center grade terrestrial Earth-based GPUs into space. It's going to be the first of many.
While it's essentially a prototype, it's still 100 times more powerful than any computer that's ever operated in the vacuum of space. To find out how they went from an idea to launching a demo satellite in less than 2 years, we visited StarCloud's HQ in Redmond, Washington. Tell us about what StarCloud is working on.
We are building data centers in space, initially to provide GPU compute to other satellites, and then later to compete on energy cost even with terrestrial data centers.
StarCloud's goal is to build the world's first orbital data centers, massive GPU clusters powered by constant solar energy to run AI compute at scale. Operating in a sun-synchronous orbit, they'll draw uninterrupted sunlight for energy, radiate heat into deep space, and run with zero fresh water and much lower carbon emissions than data centers down here on Earth. By taking the cloud off Earth, StarCloud can scale almost indefinitely, free from land, grid, and cooling limitations, and ultimately compete with the cost of the largest terrestrial data centers. Tell us more about how far along you are.
We started about a year and a half ago. We've designed, built, and tested our first satellite, and that will be the first satellite that will have an H100 from NVIDIA on board. The purpose of this is really to prove that our thermal management and radiation shielding techniques allow us to operate the state-of-the-art in space. We're going to be running a whole bunch of demonstration workloads on that. We'll be the first to run Gemini from Google on there. We'll be the first to do fine-tuning of model and training a model in space.
Why data centers in space? It seems like, people are still struggling to get the compute that we need here, building them on Earth. Like, why is space going to be the next frontier for that?
Yeah, so we see a world where almost all data centers, anything that doesn't require very low latency, is operating in space, purely because of the constraints we're facing on energy terrestrially. And so we're building with a vision to build extremely large, full 40 megawatt data centers. It's about 100 tons. It's what you can fit in one full Starship Halo bay.
And if this works, what does the world look like?
It takes a huge burden off the grid on Earth, both the grid and the water supply.